So I'd like to introduce our first speaker, invite Michael Arnold to come up, and Michael is going to tell us about on-site soil nutrient analysis for smallholder farmers. Thank you, Michael.
So good morning, everybody. My name is Michael Arnold. I work with John Hart and Chintan Vaishnav. There we go. So I'm going to talk about our work developing a system for farmers like Praveen to measure their soils and improve their crop yields. So Praveen here is a sorghum grower in India, so that's largely where we work. So to start off with the basics, crops require a host of nutrients. Most critical are nitrogen, potassium, and phosphorus. Soil pH impacts the capacity for these plants to take up these nutrients. So if you look at the plot on the left here, is what happens when there's a deficiency of one or more of these nutrients. So this can impact yield by greater than 50%. So it has a significant contribution. And critically, the yield is determined by whatever's most limiting. So it's important to measure all three of these to start. So if you look at the distribution of yield gap challenges around the world, yield gap is the difference between the potential yield of a crop and what is actually realized by the farmer. So this is a problem with global distribution, and the areas that we want to focus on are where there's the largest gap. So these are the opportunities where amending these primary macronutrients can achieve significant results. As you narrow that a little further, the opportunities are through other nutrient measurement. So optimized nutrient management on the farm yields benefits in yield and profit to the farmer. So compared to a farmer's existing fertilizer practice, a soil test-based input schedule or fertilizer schedule has been shown to improve yield by 14% on average, 13% for profit, and critically, the fertilizer use efficiency is significantly improved as well. So the question is, why are farmers not currently testing their soil? If you look at the landscape in India, for example, there's two primary options, really one, and that's a testing lab that's offered by a government-sponsored entity called a KVK. The challenge here is that there's roughly one KVK for every 215,000 farmers. So, and throughput for these labs is a few thousand samples per year. So there's a backlog. Oftentimes the farmer doesn't get their results in time for them to act on it. The other options are colorimetric field kits. The challenges here are so this is my colleague Nikhil, deciding whether this is a low, a medium, or sufficient levels of baseline phosphorus in that soil. So the subjectivity is critical. So through workshops and interviews with a number of farmers, the takeaways are that we need on-site analysis. It needs to be a system that can be readily used by an unfamiliar user, and something that's accurate and low cost. So here is a video of the system that we're developing. Effectively, you take a composite soil sample from the farm, so this is averaged around the farm area. You mix that into an extractant solution, so that's a dilute salt. We have some consumable ion-selective electrodes, which is the primary focus of our work. That's inserted into a electronics reader, so that's effectively a high impedance voltmeter. We do a 2-point calibration solution to improve the accuracy, and at the end of this procedure, the soil nutrient levels for all 4 parameters are displayed. That information is then communicated to a smartphone, which takes the results and produces an optimized fertilizer schedule for the farmer. So our primary focus of our work is to take an established technology, which is ion-selective electrodes, and change the architecture into a planar form, thereby lowering the cost. So effectively, we're making an open circuit potential measurement. We have a laminar or a printing process where we produce these different layers, and our output is a potential. that effectively corresponds to around 60 millivolts for every 10-fold increase in concentration. So from this information, we can accurately measure what the nutrient levels are in a soil. Ooh, that looks terrible. So apologies. So if we compare this to the existing modes of testing, the benefits across the board we're hitting all the parameters that we're looking for. So improved time to results is around 10 minutes. We have, through user testing, shown that a user without experience can correctly perform the test. Price to the user is around $2 a test, which is roughly 50% of the sponsored lab. And the accuracy is plus or minus 10% relative to a soil testing lab here in the States. So moving forward, our target beachhead market is the farmer-producer organizations within India. So if you look at smallholder farmers, roughly 125 million in India, so that's less than 2 hectares. Farmer-producer organizations are aggregators which serve as a trusted node within their communities or collectives of farmers growing similar crops. They have established trust with their community, and so our focus is to provide a tool that is used by these farmers and or these networks. So with that, I would like to thank everybody, and I look forward to talking to you at the poster. Thank you.